I guess I would want to start out by saying that years of experience are one thing, but hands-on is even more important. And so the last 16 years, we really have, especially in the group I work with on the thermal efficiency side, have really focused on furnaces and fired heaters and trying to maximize their operation, meaning take care of limitations, right? By inventing and installing technologies that help extend those run lengths. We've got some great bullet points there that all make sense that we're all looking for in our jobs and how we run our sites. But the focus has to be even more specific, right? You're into a safety envelope and you want to make sure that you can keep yourself there. You don't want to drift. Relieving limitations by default means you're improving your margins, and that's what our plants are built for. And so we really are highly focused on that topic. Today's material is really educational. It's just meant to open the menu up of the kinds of technologies that we routinely install and ones that we've developed over the years. And this platform is absolutely perfect for this kind of sharing information where we have direct experience, customer data on a global reach in terms of our ability to execute. So this is a great way to open up the door to give options that may not be let's say recognized or people may not be aware of. So thank you very much for that opening and giving us a chance to do this. Nick, if we could go to the next slide, let's see how we can, there we go. Perfect timing. All right, so regardless of the location or geographic region that you're in, all of our plants were built for having the maximum efficiency possible, right? And by virtue of that, we share the headache of accumulated headwinds during our operations, during our runs, and limitations come in a whole variety of sizes and flavors and cost and risks. And from the world of limitations, some of them are just a nuisance, as you well know. You just tolerate it. Some of them, however, could be at the other end of the spectrum and can be very costly. And so that whole spectrum is what we want to discuss and what we'd like to have our technologies bring you relief on various limitations. So our process teams like yours are focused on these. For instance, you may be facing a draft limitation in a unit. Now you're making plans for the next turnaround. What can we do to adjust the unit to take care of that draft limitation? And that's exactly how you should be doing it, looking at significant limits and what you can do to help yourself by virtue of days and dollars in the turnaround. However, there is some relief that can be found from the online options. And those online options come in a wide variety of, let's say, technologies that we've put together over the years. Now, from a from an execution standpoint, the first way to look at your limitations is to be able to physically understand what you're facing. And that's why one of the things we did early on, meaning some 20 years ago, we came up with a high temperature Landscope camera, water cooled, air cooled, light sources, all the things you need to be able to put that unit into operating units. We put them in coal burning fire units. We actually originally developed them in glass furnaces, in float glass. Now you can imagine what that furnace is. Those temperatures are, let's call it 1,000 degrees F hotter than what you'd see in a downstream unit. So we're well versed in operating in high temperature situations because we started this with water cooled and air cooled and light source cameras. Because what's the most useful thing? If you have a defect or a problem with your heater, how do you diagnose it? How bad is it? How far is it spread? What is happening to my refractory? How much fouling do I have? Where's the hot spot at? All of those things we'd like to help you be able to wrap your head around diagnosing it. And that's what that Landscope is all about. And each of these services you see listed there came out of that. A customer said, geez, now I know how bad my refractory damage is, or how much has fallen off of the transition zone, or how much fouling I really do have and where it's accumulated. So, so these services, which are all built to buy you relief between turnarounds, you're in a great position by being able to inspect it because then you can decide, this is a serious situation. It's worse than I could tell from the outside. Let's just go ahead and shut the unit down. That's a fantastic use of that tool. We can go to the next slide then, Nick. So when I talk about hot inspection, to me,
Hey,
it's a,
Larry, sorry to
yes, sir.
interrupt you, but
Well,
if you
thank
would mind, would you go back to that first slide where you had like the five different use cases
Oh,
or
sure, sure.
reasons why?
Sorry,
If,
Greg. I tend not to take a breath, so that's perfect timing. Thank you very much.
that's okay. For the benefit of our listeners,
Yes, sir.
acronyms frustrate a lot of people.
Oh, yeah.
So when you have BWT and TMT, I can guess what you mean by those, but would you
Good
mind
catch.
stating what they are? And if you would too, say a little bit about those different challenges so that we kind of frame things here for the
Sure.
listeners as we go through.
No, perfect, perfect, perfect interjection there. BWT, bridge wall temperature limits. Bridge wall temperature, that magical zone between the radiant and the convection section. That area is critical in terms of monitoring the unit because you don't want to be too high. You're going to start causing collateral damage in your convection section, for example. A bridge wall temperature in the radiant section means you probably can't get any more throughput because you're already in let's say outside a good operating scope. TMT, tube metal temperature limits. We're often doing FLIR camera inspections, and let's see what that tube metal temperature looks like, the surface temperature, the tube metal under it. So that's another very big indicator that we all use for maintaining our units to see where we're at in the operating window. Thank you for doing that. We
Oh,
tend to
thank
all
you.
fall, we tend to fall into our own languages, don't we?
Yeah, I totally, I've done it myself many times.
Perfect. Did I answer the question then?
Yeah, I think so.
Okay,
Yeah,
right,
yeah.
right. Then let's go one past hot inspection. We'll go right into a great picture. So the land scope I talked about earlier, what's important is that we can help a customer understand the before and after. If you're going to do work inside your furnace, no matter where it comes from, this is a fantastic tool so that you'd be able to say, okay, it isn't as bad as I thought, or when that piece of fiber refractory fell off, it only landed on the north wall on the far edge. Right? I mean, you can really do a great job of seeing how bad it is up front and then what the final results are after you do that kind of work. What a great confirmation, because there's never enough doors or access points in order to do that. Nick, we can go to the next slide now. The inspection continues with using the camera to truly diagnose. We did this for a customer where you can see the castable, how it's failed. I'm sorry, Greg, was that a question?
No,
Oh,
no.
okay. You can see where we're zooming in so you can get a much better idea. This is a transition area between radiant and convection. And we not only were we able to say how bad it is, we could also project the secondary area that was also falling out. So even though you couldn't tell from the roof how bad it was, we could from inside. So it's a great way to diagnose, we better shut this down or we better fix it. Whatever the strategy is, let's get a clear indication of where we are. We can go to the next slide. And you can't do this kind of work with a camera without being able to create access, right? We all know there's never enough inspection ports or the damage is never in sight of where you can get in and see. And
Hey,
so we
Larry,
have,
Larry, excuse me. Quick
yes, sir.
question going back to that previous slide.
Oh, sure.
When you've got that camera, you're looking inside the heater.
Hmm.
I see here where you've got kind of like a long range shot or picture or view. So you can look at a lot of surface area at once. And in the previous pictures I've seen, you can zoom in and look at
Hmm.
areas.
Hmm.
Are you able to look at, or are you able to get any qualitative or quantitative measurements with the camera? You know how they have light box technology and other things now where you can get a little bit of relief measurements, on things like how heavy is the scale, how far away is this one thing from another, so that if you're designing a fix, which I think we're going to get into
Hmm.
later in your presentation, if you're going to actually do something structurally to hold things together better or to to restrain them better. Are you able to get any measurements, or is it pretty much just best guess visual?
Yeah, it is not going to be a measurement tool for you.
Okay.
The capability here is more of a diagnostic exactly in terms of what can we do. And this kind of visual is enough for us to be able to design a repair actually around those two areas. So for us, it's appropriate and gets us far enough downstream to be able to add to the customer's knowledge of the situation.
Okay.
It's always surprising how much damage there is to be fair. It may it
Huh?
and
Go ahead.
customers can't always see that from the outside, and they're
Right.
usually surprised when you bring the video into the conference room to
Okay.
see what the situation is.
And I guess you work hand in hand a lot with the people with the thermography cameras and stuff, and knowing where to go to in the furnace if it looks like there's some kind of a heat sink or some excessive buildup of scale or something. I'd assume you work hand in hand a lot with
Oh,
thermography.
we own more than a handful of those high temperature FLIR cameras, right?
Okay.
We're a great tool. We've used them for years. It's sort of a hand in glove, right? It comes right into play with understanding the situation. Shell temperature is one thing, but looking at those tube temperatures is even more critical. So
And
these are all great ways to narrow down what we should or shouldn't do for the heater.
okay, and I assume too, then on the fly, you're consulting with the customer and determining where you should look or what he or she wants you to look at. Have you ever gotten that lance or the camera stuck and couldn't get it back out or something?
No, no, nothing like that. No, pretty straightforward. But you did bring up the zooming, and we've got the lance we can rotate, so you could put it in and look at the roof and spin it and look at the north wall and the west wall, and pretty flexible. This camera comes on various lengths of, put them in a 30-foot lance to hold it and push it across the heater. So a lot of flexibility. You can really zoom in on what
Okay,
you're trying to determine. So
great.
great diagnostic tool. Thank you.
Thanks,
Thank
sir.
you.
Thank
Sure.
you.
So we're on the hot access creation. There we go. At the end of the day, we have to be able to get into the heater, and that comes in a variety of sizes and shapes. Here's just a traditional example where we needed something a little bit longer because the lance was going to pivot, if you will, like wipers on a windshield. And so there would be I don't want to call it a door because that implies a hinge, but this plate, if you will, is already on threaded studs that we attach to the shell. So in some cases, 5 years later, 10 years later, we want to go back into that area and maybe do additional cleaning. In this example is what that door probably was for. So we were able to remove that if there is ever is a second event. And that's just one example, whether it's down to a 4-inch diameter to put the camera into or something much longer. Sometimes we'll put them in routinely along a convection section bank so that we can get in between all the tube sheets and see everything we need to. But you have to be able to do this safely. Plasma cutter, take the shell off. Then you want to be able to remove the refractory. You don't want chunks of this falling in on the inside of the heater, so we're very methodical, a lot of very precise steps in order to prevent that from happening. And that's all part of the ITP, right? That's all part of our work progression so that you're comfortable with working on a live heater, which most people don't necessarily have firsthand knowledge with. But we can go to the
I would
next.
assume, Larry, that
Yes,
most
sir.
of the time the customer performs a job safety analysis prior to your doing this work, and you guys have input to that, I'm sure, in procedures that you follow and requirements. And one of the things is a lot of these heaters, I guess, are supposed to be under a negative
Oh yeah.
pressure,
Yeah.
but that's not always the case, depending upon where you put that hole in there. Sure, I assume all those things are addressed as part of the JSA.
Yeah, we don't want a second meeting unless we are talking about JSAs and JHAs and the safety folks are in the room. That's the
Yeah.
last thing you want to do is get too far down the road conceptually without answering those very pragmatic questions right up front.
And you want to
Absolutely.
have your eyelashes and eyebrows left and intact and all
That's
that
right.
good stuff.
That's right. Yeah, you don't want it to burp on you, that's for sure. But that's exactly the point, right? If someone calls and said we have a positive pressure item or a unit, or we have some pipeline you want to work on, that isn't appropriate for these technologies. We've done a couple of those where you have the double seal and it's all flexible, but frankly, it's rare that the problem is bad enough where that's appropriate. So the lion's share of the work we do would be on neutral negative draft units. I always like to say once you that slide before that where you saw the red slit in the wall two back, once you cut that slit on, this is a shell of a heater that's failing. When you do that, the flame isn't coming out. If anything, it's going to pull your hard hat off and stick it to the wall. I mean, that's really what's happening there. So we're very much aware of how to shield ourselves, how to protect, how we insert the equipment, how many of these slots are open at any given time. Because you're right, we're thinking about the air going in. All that is very comprehensive as we go through it step by step because we're process folks too. So
Okay, thanks.
sure, sure. We can skip ahead to the hot refractory repair picture. There we go. Actually, let's go back one more because I wanted to just make a note about the shell here. You can see how warped that is. That was the customer made an attempt to save themselves, meaning the shell itself was failing. So they put this shadow box, if you will, around the outside of it. And unfortunately, the way that worked out, it actually accelerated the failure of the real shell. And so that really didn't buy them anything. So we got out there pretty quick. And this is actually Jim starting the first cut to get the first slit into the wall itself so we could put our own internal wall in. Go ahead, Nick. Thanks for thanks for being so flexible on all these slides, Nick. So when we're looking at those repairs, we'll come back to the customer, back to your question, Greg, and we'll design a methodology for the type of failure they have. We have a variety of techniques. Some call them baskets. We like to use that word sort of generically. Think of it as a high temperature steel, a stainless steel. We might put refractory on it. We might not. All depends on how thick we need it, how much refractory has to be filled, what temperatures we're chasing. But we'll put together a very specific step-by-step scope. We can go to the next picture. Maybe this is a better way to describe it. The customer here had a very large area. All those orange blocks were problem areas, putting steam on it. What are we going to do? You can see on the far upper left, it's a big piece of the roof. And that's what that bottom left picture is. It actually burned right through the roof. Now this is on more the extreme end of what we see, but it's important to give a feel for we can do large areas. And there's your IR images that we're mapping the unit, right? So we can see how bad is it, where is it going. And the three pictures on the right are all the completed repairs and what it looks like afterwards, because that's where we bring the infrared camera back out. We'll show the shell temperatures. You can see the variety of welded patchwork, if you will, that goes over the top of all the work we did on the inside so that the customer has something that is a long-serving repair for them. Now, some customers have told us, geez, this thing's been in there 8, 9 years, right? But everyone should, if we do these repairs, at the next turnaround, do a thorough inspection and decide if you want to go back to original design. By and large, these are going to more than serve what you need. But I thought that sort of that progression might be a good way to get that in because nobody wants to have the meeting about shutting the unit down if in fact you can keep yourself in a safe situation and have a long-term fix. And that's
Larry, that
usually,
looks, I'm
Mhm.
sorry, go ahead. Go
No,
ahead. I was going to
no.
say, this looks kind of probably, I think you had suggested an extreme case,
Mhm.
but can you give us some idea in that color image with the IR,
Mhm.
how many to scale, like how many feet of area are we looking at there? Is that like 8 feet or 10 feet
Yeah,
by
that's
4 feet
exactly.
or?
Yeah, your instincts are good. It's exactly right. Yeah, think of it as sheets of plywood
And
areas.
the
Yeah.
repair, are the weld repairs being done while the furnace is still operating as well?
Yes, we're welding the skin back on when we're done
And
because
you guys are designing the repair and
Mhm.
installing the plate and so forth?
Yes, sir. Yeah,
Okay.
turnkey for us. We need some help with platforms and getting equipment up there, but we'll be doing the work. Next slide then, Nick. Here's another way to look at it. I thought I'd break it down into pieces. There's that same bottom left shell, right, that was failing. So the upper picture, we cut access, and inside that slot, you can already see the backside of our wall. We put in a fake wall. Sometimes I say, imagine an umbrella you put into the unit, pop it open and pull it back up against the wall, weld that right to the shell. Now you have an interior wall that we've already have some, let's say we might stuff it with blanket, but then we're also on the upper right-hand picture going to fill it with pumpable refractory because we're going to figure out how thick the inside wall needs to be, what temperatures it's going to see, which product is going to give us the right insulation value. And then bottom right, we're taking infrared images after that pumpable is cured for, let's call it 8 hours or so. And now you can see the purple at the bottom of the picture is the repair area before we put the next basket or tile or layer in. So we're going to just work our way up the damaged area, and you can see how cool that is, right? If you're looking at 536 down to whatever that new temperature is. So it's a great way to prove you have a great fix. And then just put the steel shell back over the top of it. So just to give you a sense of the progression. Go ahead, Nick, next slide. And usually our conversations start with how many days would it take if we shut the unit down, right? And that's a tough place to be for the client. But if you look at these IR images, upper left, if they started at 280C and we upper right took them down to 70C, they're back where they want to be on that shell temperature. Same thing on the lower, right? 280 down to 180, 118. So it's just a matter of before and after, what areas can we access? And then we don't leave the site till we get it to the best temperature possible. Infrared cameras are just a beautiful tool. Next slide. And so I said extremes. Here's on the small end, even a little ducting that's problematic. It's burning out on you, and your turnarounds, what, 120 days away we have on here for a bullet point. That's nothing. You'd think you'd make it, but you may not. And it's much worse to not make it, especially if you've got shell temperatures of over 1,000, right? And the steam just isn't giving you what you need. So if you can fix something like that in 3 or 4 shifts, why wouldn't you help yourself? It's just such a sensible direction. Next slide then, and that should play a 30-second video. Conceptually, right, you've got your hot spot. We're going to get a plasma cutter, open it up, and make sure that we do the smallest opening possible, put in the interior wall, high temperature metallurgy, weld it to the shell, put in anchors to keep that pumpable refractory in place. Might even put some blanket inside of it first before the pumpable, and then put the shell back on. Very straightforward and not as onerous as you might think for the folks on the safety side. Very straightforward.
Blair, are you able to also install new anchors for the refractory if needed?
Yes, as long as we open it from this side, we can put those right in. It's just a matter of what is really going to help the customer. Usually if the anchors are gone, then the fiber's gone too, right? And
Hmm.
so you've got to be able to patch your way around to get to a good area. So sometimes these areas can be very oddly shaped. Next slide, please. And we just chase the hot spot until we get to the end of it. Convection sections, and we're going to flip the menu here for a second. And convection sections, right? It's all about process preheat. A lot of fired heaters need that. In ethylene, it's about your crossover temperature. We all live with a dirty convection section, right? It's been accumulating fouling for 15 years. And goodness knows there's no access in these things anyway. Next slide. So we decided, why wouldn't you help yourself in between turnarounds to get some of that production back, especially if it's process preheat? So here's a very straightforward way, and we use inspection doors. We're pushing dry ice through a lance, line of sight work. Makes perfect sense to get the fouling off the leading edges. I would even say that sometimes you think about surface area. You're not going to get down into the bundles. That's correct. We're not worried about that on an online event. We can go to the next slide. It's got some data in it. But all we're doing is while it's running, we're pushing the dry ice is pushing that fouling out of the fins. The lights are leaving the unit without opacity issues, and the heavies are falling, and you're buying back a good bit of what you've lost. If you think about us cleaning 20 or 30% of the surface area in this methodology, but you've got 40% of your fouling there, you can really have a win. The data here talks about saving 6 million BTUs, an hour of fire duty, a payback of 6 months. I mean, these are the financial numbers you have to look at because we all live with fouling. It's just a matter of when you don't have to anymore, when you can make a spend that will more than pay yourself back for the next, let's say, 2-year run or whatever it may be before you get to your next turnaround. So all these numbers come right out of the control room, right? Furnace efficiency increase, undeniable. Your fire duty goes down, but your absorb duty is the same. 100% win. Next slide. And that data is all about process preheat. If you have a catalytic reformer where you really need the steam, right? How many people are steam long? Not so much. So we can get that fouling off those leading edges and buy back a good bit of it. Here's a pretty amazing example, right? Almost a ton of hour per steam, a nice payback for the customer. But by being able to put the camera in, see where the fouling's accumulated, doing the calculations on what that surface area would bring back, the customer can make a decision before they ever execute. And then the control room has answers at the end of the shifts. You start seeing the results. Next slide. It puts you in a place where conceptually your folks are saying, okay, how many bundles do I have? Which bundles are critical? I'm worried about the economizer or superheat, whatever it may be. So just so you had a feel for when you do it online, that lance is going to go in between each of the bundles. It's not like a snakehead where we're going to wind our way into it, but we are cleaning the leading edges from the bottom up and from the top down. So you certainly can make a meaningful difference on that first row and whatever face is exposed on the second row. It's a great way to buy time, especially when you know everybody has that problem heater that they're going to do something in the turnaround. But some of those middle range heaters, this would be enough for you to feel fantastic about getting back some of that efficiency and a very straightforward event. Again, cutting access, before and after photos, and you'll see the results in your control room. Sometimes people say, could you stay 2 more shifts and just go through it one more time, just so we can get a little bit more out of it, as long as you're here, right? Because it's such a straightforward win. Go ahead. Let's go to hot tube stabilization.
Just a
Greg,
couple
yeah, I was
questions
going to say, Greg, was
on
there something?
cleaning.
Yeah,
Yeah, I was holding back until you got to the end
you did great.
there. So, you were showing convection section
Mhm.
cleaning. Some of these reformers are made of some pretty exotic alloys. Some aren't. But in either case, a lot of times creep damage can be an issue in them. And of course, if I lose any of my tube metal wall, that can affect the creep progression rate. Does this method using the dry ice, does it eliminate or mitigate the probability of getting rid
Yeah.
of any tube wall thickness?
No, we're simply we are not going to do any damage to the tube walls, right? I've seen some pretty frail ones, and the dry ice is pretty effective, yet
Yeah,
not aggressive. It's not like grit blasting. You'd imagine
right,
the kind
right.
of the kind of impingement you'd have from that. So surprisingly gentle and effective is the way
Okay,
as I would put it. Now, when you get to that sulfuric cement that you see right down inside the bundles, that's a different event, different tooling. This is an on the run. Just buy me back another 10%, please, right, in
right.
my convection section.
So you're not abrading any of the steel
Absolutely
or
not. No,
metallic structure. Good.
not at all. Not at all. But
Okay.
pretty good question. That usually comes up in one of the first meetings with customers, right? What's the downside? Are you going to do it? What's collateral damage look like? It's exactly
Right.
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 So
Okay.
here's another. No, that's great. That's great. I'm sure that would be a common question from the audience too. So the hot tube stabilization, we all know what that sounds like when you walk past a heater where a couple of tubes, on the north wall came off of their hanger, and the first one let go and it brought the second one, and now the third one looks like it wants to. Nobody wants to walk by those. This is actually a nice close-up picture of threaded rod, which is the other end of what we've installed in that heater. Think of it as a shepherd's hook, an adjustable shepherd's hook. It might be a good way to put it. We can go to the next slide. Now, these pictures are a little funny in a color, but you can see in the upper right hand where the two dark rings around the tubes, that's the business end of the shepherd's hook, or the bottom of an umbrella handle, where we made access in the wall, knew where the tubes were, fished it through there, and put the shepherd's hook parallel, and then rotated it and pushed it back up against the tube. Now, I would tell you it's not smart to pull that tube back into place. It got there for a reason, right? Leave it where it is. We just don't want it walking any farther. We just did a job in Europe where they had 4 of these after we inspected with the camera, and we ended up doing 13 of them because they just didn't know. And we could see through the camera how many more were following the same pattern. So it's a great tool. This, you know, vibrating tubes, mostly a nuisance, but once it starts accumulating, why live with that? There's no reason to. A couple of 3 shifts, you're back where you want to be. Don't have to think about it. So hot tube stabilization is often one of the things that customers do first with us because they're trying to get used to doing online work. They want to see how it all gets organized, how we operate, and this is a great way to do that. The next slide then,
How do
Nick.
you make sure you're not
Mhm.
over tightening that nut, to where you are actually pulling on the tube?
Well, that's the beauty of having cameras coming in from every angle too, right? We can get real up close and personal with our Landscope camera and see where we're at. We can cut access from any angle. It's not a matter of feel, right?
Yeah, yeah.
we can see what we're doing.
Okay.
And that's why these pictures might be a little more helpful. That upper right, you can see the black bar at the end of the shepherd's hook that's
Hmm.
already installed and put up against there. And so we cut access wherever we need it, and using the threaded rod. I'd say we use threaded rod 3 out of 4 times. Some places it's really not necessary. And then we'll backfill it with a pumpable refractory and button it all up and let her go. And then customers can make their repair, if you will, in the next turnaround, right? Go figure out what they'd like to do a little bit different. Pretty popular, just a normal event that people can work with. So we're going through the menu here of when you have these runs, these 4, 5, 6 year turnaround runs. I mean, it used to be 3 or 4 was an amazing run. Now, right, there's pressure to run 6, 8 years. So these things happen more often. They just accumulate over time. And so it's nice to be able to have these kinds of options to review and consider. In some cases, it won't be a good idea because we're going to go through, I mentioned collateral damage as a great topic. That's what we would want to do, is assess the situation and decide, is it appropriate to do that in this heater, in this service, at this temperature. So there's a whole lot of work up front, cussing and discussing, I like to say, of the situation to make sure it's an appropriate use. And frankly, you probably want to talk to folks we've done this work for in the past also. But it's a great stopping point here, just to say all these technologies are becoming even more popular because we're forced into longer runs. And so just having the menu in the back of your mind can be helpful down the road. Let's go ahead and pivot over to the hot vacuuming. So this is a little different animal. We talk about fouling and convection sections before, right? Crossover temperature process preheat protection. Now we're talking about an SCR, the catalyst. Very expensive equipment, right? And it's all about pollution control, ammonia mixing, getting it right. But it doesn't take much, surprisingly little, to foul these up. I don't want to say dryer lint, but it takes so little. Matter of fact, when we vacuum these off, you're talking about 5 gallon buckets worth of debris, not drums. So just to kind of give you a sense of the volume of material, how little it takes. We can go to the next slide then, Nick. Nick. So what's going on is as that material is going downstream, right? You're getting all the pollution control you need, all the ammonia mixing. But when you start getting into that pressure drop, it can really start diverting the flow. You're using more ammonia. The fans, I mean, the whole thing just rolls in right over the top of itself. So we got a call from, in this case, it was actually Air Products that called us and said, we'd like to find a way to sort of make the emergency repair. Sometimes you start a unit up after a turnaround, and it seems like you shook everything loose, and all of a sudden it's right back on the catalyst, and you don't feel any better about where you were. So we came up and patented this online vacuuming. Awesome way for us to, whether it's horizontal or vertical, we can remove that fouling while the unit's running. I mean, some places are lucky, right? They have a twin unit and they can switch over and they can make it to the turnaround. It's every 2 years. But in some cases, you don't have that luxury. And of course, it's very easy to do that offline, but doing it online and making sure you don't damage the face of that catalyst, let's go to the next picture, is really important. And so it's always back to access creation. This one was actually a double wall on a catalytic reformer. So that was even more complicated that you have to deal with. Again, inspection, cameras, GA drawings, all that rolls up to a good process. And you can see how we backfilled the inner wall, put the foam, put the insulation back over it, put the plate. I'm quite sure we'll be back there again because fouling seems to be, right, never goes away. But getting access, getting the customer back to essentially design by just vacuuming over 4, 5, 6 shifts, huge financial win for them to be able to not have to cut rate and go another 18 months, whatever the run is they're trying to get. This last shot actually is a little bit of a video. We can go to the next one, Nick. So this one actually shows the head gliding across the surface and pulling that fouling out. We actually did this 2012. We presented this AICHE with Dr. David Graham and Dr. Oliver at Air Products. It's just a fantastic tool. I hope you don't have this headache, but if you do, what a great emergency reply. Just get you out of trouble, couple shifts, done. So wherever your SCR is installed, right? It it should be at 4 and you're at 20. You don't have to live that way. You don't have to shut that down. It just costs so much to make that back up. There we go. 4 shifts, done and dusted. But that's just a great snapshot of we didn't know that was a problem. Customer said, "Hey, what do you think about this?" Right? 100 days later, we're vacuuming down in Luling. So these are the kinds of things that have grown out of necessity, grown out of our let's say customer interactions. We can go to the next slide. And and developing these helps the whole industry. Now we do this around the world for customers. So hot tube descaling, and one of the last two I'll talk about here. Hot tube descaling, what does that really mean? The radiant section, some of those metallurgies, 2 1/4, 5 chrome. Think of higher temperature units like CCR, CRUs, right? You get a good bit of scale. Now they're built for the allowance, right, to tolerate that. But sometimes that scales like tree bark. It gets so thick. Now you're not even sure, should I cut rate? I got my temperature alarm going. I'm calculating numbers that scare me a little bit. Is it the emissivity setting on the camera? No, right? You've got a lot going on these high temperature tubes, especially when they've been running for the last decade, right? And that scale almost doesn't stop growing. Here's a way to not do a full sweep. I want to make sure I really say that correctly. We're not going to clean every tube in that unit. That's just not sensible. But if you've got select areas that are problematic that are causing you to consider cutting rate, or you're hitting a bridge wall temperature limit, a tube metal temperature, as we said in the very beginning, this is an ideal method. We can go to the next slide. This is an ideal way to buy yourself some breathing room. Another kind of lance that we have, we're using line of sight. We're pumping, in this case, walnut shells would be a great kind of abrasive for this. Now you've got dense scale on those tubes. You're not getting out, without a real blast. But the loose scale on the surface is what puts you over the top on your tube metal temperature. It's what got you into that unsafe condition, if you will. So by doing the sweep of the loose scale, we're getting you back down to a temperature you can tolerate, that you can live with and not have to cut rate. So now imagine, let's actually, we can go to the next slide. Imagine, if you will, in this heater, it was just the bottom 7 or 8 rows. That's awesome. That's still a pretty big surface area, to be fair, but at least it's isolated and you can get ahead of it. And when you think about getting a 200-degree temperature reduction, when you look at that inspection, boy, that puts you right back in the game. And I don't care if your turnaround's in 6 months or 26 months, you don't want to be running with those kinds of temperatures. So let's pull you back into the safe zone, and you can run with that. And it all goes back to the visual inspection, to the infrared inspection. All of those things dovetail together with before and after. What are we trying to accomplish? Can we help the customer? And and back to the refractory. What's on the tubes behind it, right? Fiber is going to be a lot less tolerant of any kind of rebounding of walnut shells than a castable would be. So that all goes into the consideration of how do we approach this? Should we approach it? How much should we do? Uh, but again, it's just prudent to use it for exactly the hot spots. What is what's the old, twice as much medicine doesn't make you better twice as fast, right? That kind of so it's just use the tools correctly. And since we're the operators, we are the people who do the work, we know pretty good where you want to be with this. We also know when we're not going to let you get out on the thin ice, because we're not going to do it. So rest assured, we might be more conservative than you are. Uh, so I had one more topic, but Greg,
I had
I
no
saw your,
questions. You did a
okay.
pretty good job. Yeah.
Oh, I saw your head nod and I thought, oh, I might have had a question there. Or let's go ahead and touch on the last topic. Now, tube shielding, it's both interesting enough and online, where we've done it online. Pretty rare that you have all the right parameters, but we've done it online. But offline is a little more common in terms of the number of jobs. Either way, customers have problems with mass flow, right? Gas, liquid phase, all those headaches that go into operating the unit, and they're not in a position during that time to do any sort of real repairs. So we have worked, because of our own process engineering, our bias, right? We're using all the fired heater software, HTRI, Aspen, all those things. It all comes into how much shielding is appropriate, what thickness of what kind of fiber do we put coating on it, what kind of wire do we use, where do we stop it, do we put thermocouples underneath? I mean, that's a whole package of protecting you on that heater for the next run, so that you bought time to be able to replumb it, so to speak. And so shielding, because it's a unique problem, really kind of falls into our world many times, because of our understanding of not only the tube metallurgy, brought up creep and carburization and all those things that come into play. You have to be pretty sensitive to the tube metal temperatures. Next slide. And so we've done a variety of wrapping combinations to help customers be able to get the maximum production out of that, to buy time for them to make permanent repairs down the road. And sometimes it's in the radiant section, like this was for P66. Other times it's a transition zone, like we did for BP in Europe. So it's the unusual that we look for, and all of these menu items, these are the most common. All of these have come from customers saying, "What have you ever done with? We've got all this dusting. We used to burn oil. Now we've got all this debris on the top leading edge of the radiant. Can you get that off of there for us to help us with heat transfer?" You don't, as you look at your heaters and your sites, you may think you're the only person on the planet with that headache. I assure you, you're not. And we've probably been to the site that has. So just give us that opportunity to pull these into your site and decide what's appropriate. Uh, that my intent today was to to just open this menu up. We can go to that last slide. I mean, the folks online here, Greg, Jeremiah, Nick, you've been very helpful to help me understand how this runs and the way to put this out there. I hope that this was got across the message that you were asking, what is it that you actually do? Because online maintenance is just becoming more popular, if only because of the runs we're burdened with, if you will. And frankly, you can't let your margins drift just out of inconvenience. So if you don't know you have options, right, you don't do anything about it. And so we all have the little nuisance things, but some of these, some of these, let's say, technologies can really be very cost effective and put you in a much better position for another year or 2, 3 years of running. So it's a great middle of the road for you.
Are
Right.
you able, Larry, to install skin thermocouples if they need them?
Uh, we could, but that's not a mainstay of our
Hmm.
technology. I mean, it's not a normal thing. It's
But you
like,
could.
yeah, yeah, we can get involved in that, or maybe you want us to help you with burners on site in a turnaround because we're
Right,
working. I mean, so there are other things that are in orbit around us, and
right,
we do on occasion, but that wouldn't be uh, a normal fit for us because these are all technologies we've invented, right?
right. I
Um,
remember working in the plant. We had some big old boilers there,
oh,
and sometimes we'd have problems with our tweer nozzles that are meant to clean the scale or the buildup off the tubes. But sometimes they'll malfunction,
yeah.
and you need to see those kinds of things sometimes to understand what's going on. So, do you guys look at those things sometimes for people?
We would. I don't have a case study exactly to go a little bit
Okay.
deeper than that, but it's no different than putting in a box because you want to install some specialty burners or inspection equipment
Hmm.
or a gold cup unit, right? And so we can do online install of bracketry and things like that if a customer is going to have something else installed. So
Yeah.
we're really right there in the touching the heater, which a lot of people shouldn't, and we just happen to be pretty good at it.
Just for the sake of our
Oh,
listeners, I
sure.
listening to you, I'd encourage them that if they're going to think up something that you haven't covered already,
Yeah,
but they kind of understand some of the things you can do with this technology, that they could contact you and
absolutely.
discuss
Absolutely.
potential applications.
Sure. Sure. We'd love it. We'd love it. We got a call from actually, it was Valero. Valero, now that I think about it, they were building a new unit and they said, hey, you do this online convection cleaning. I bet there's an optimum number of doors, right? So why don't we do it ahead of the curve? Let's be smart about it. It's a lot less expensive then. And now you have that tool forever because
Yeah,
the south side's full of piping and tubing and there's no room, but the north side's wide open. We know how many bundles you put in 11 doors and boy, you're
that's
good.
interesting. So they're designing for this capability that they may
Absolutely.
need later.
Absolutely.
Yeah.
Absolutely. Once you start using these things, you're like, hey, shouldn't we, right? It's,
Access doors or
yeah,
ports. Yeah,
oh, for sure. For sure. It's just a great set of tools. We just want to make sure we use the wrench for the right tool.
yeah. Wow, cool.
Good deal.
Thanks.
All right. Thanks, guys. Larry, great stuff here. We're got about 5 minutes left. We had a number of questions submitted
Sure.
um, over the last 45 minutes. So let's jump in, see how many we can knock out here.
We'll take
Um,
music for 50, please. Can we do that?
so one of the first questions I wanted to ask actually was like, how do you determine whether an issue can be safely addressed while the heater is offline versus waiting for the planned turnaround? What does that evaluation look like?
Um, I'm not sure I understood. So, um,
Just online, an online repair versus waiting for the next planned turnaround.
oh, okay. Okay. Sorry. I didn't quite keep up with you there. It really comes down to the simple discriminators. Is it a positive pressure unit? No, thank you. Do it in a turnaround, right? Some of the basics. Um, is there a structural integrity issue because of the temperatures that have gotten away from you and refractories failed? No, thank you. Right? We're not going to help you on structural integrity. Come on. Is there collateral damage as a significant risk if we execute? Well, why would we fix one thing to damage something else, right? So there's some very early discussions that will go right through those to say, yes, it's a good direction. And then you move to the arena of what's my payback, right? The customer has to decide how many shifts, what will my benefit be, and where will I be at the end of this? So it's usually the safety discussion first. Is it sensible? And then what's my payback? Because it just might be that your catalyst phase is so fouled and you're shutting it down in 10 weeks anyway. We're going to take it early because other things are coming down. And so it sort of ramps right to that. But if you want to run 10 more weeks because the other unit's having a problem, well, it's time to vacuum. So it's a game time decision, right? And that's why you want to have as many disciplines in the room as possible.
Sure.
Uh,
Well, there was a number of questions when you were going over the convection cleaning
Oh yeah, for
about, and
sure.
I know you briefly touched on this, and Greg brought it up as well. But how do you, with that dry ice cleaning process, how do you ensure the tubes are not damaged or any leaks or caused during the cleaning?
Well, dry ice is surprisingly forgiving. It
Okay,
isn't going to damage the tubes. You can just lay that lance there and let it blow dry ice for an hour. Won't make any difference. It really isn't going to do any harm. Now, if you're doing grit blasting and you let that gun sit there for 30 seconds, you can put a hole in a radiant tube. You're not going to do that with dry ice. You really aren't. And we are in control of the lance at all times. So it's,
gotcha. And then for some of those
uh-huh.
uh, real heavy fouling,
Yeah,
what's happening to that after it's blasted off?
sure,
Um,
sure.
does
Yeah.
it
And
get
that's,
stuck in the tube rows or
yeah, that's part of the trade-off, right? When we put the dry ice in between those fins, we're going to push that out of there. And anything that's light enough to be carried out by the flue gas, it's going right out the stack, right? It's never enough volume to be an opacity issue. But if the heavier chunks will literally fall down into the bundle, to the next bundle, to the next, right? So you are pushing your dirt downhill. So that's why we like to clean from that top, come down and clean down again and clean down, do the best we can to help ourselves. But an online event is not meant to be 98% of the surface area clean. It's meant to get you out of a 10-year headache to get you back to a serviceable condition. And then you're going to do the thorough cleaning in the turnaround, right? So this is a great tool, but it's not your final answer.
Yeah, but at
If
least
it's
you do
yeah.
improve the heat transfer
Oh, absolutely.
enough. Yeah.
Absolutely. And the control room will see it at the end of the first shift we're cleaning. I mean, you just see it every day. Tick, 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 tick. Life gets better with every shift.
Mhm.
Very straightforward.
is there a minimum clearance needed for the convection cleaning?
Well, the tube's only a couple inch diameter, so no. No, usually the space between the bundles is 5, 6 inches at a minimum. That
Okay.
seems tight. The lance is half of that. I haven't been to a bundle that I couldn't get through. Now, if the bundle below and the bundle below are right on top of each other, well, I can't get there. That's it, right? Tube sheets could be in the way, going the other way. But give me 2, 3 inches and I can do a lot of good work for you.
How much of that is guesswork, Larry, and how much of that can you accurately estimate up front? That is, what if your clearance is going to be sufficient to get how far into the bundle? Is that guesswork, or you have to get in there, or from the drawings can you tell, or
Oh, I
how
see.
would you do that?
Yeah, I should say it another way. We're not going to get into a bundle. We're going to do the outer perimeter
Right.
of each bundle.
Yeah,
That
that's
would be
what
a,
you said earlier.
yeah, I
That's
just
what.
want to, yeah, I want to make sure I didn't say
Yeah.
it wrong before. Yeah.
No.
So we can do a very good job of getting in that seam and cleaning uphill and downhill, but you're not going to push anything any further than that.
Okay.
Matter of fact, if you've done chemical cleaning in the past, you've
Mhm.
probably already taken the easy fouling off and it's largely accumulated in the middle of those bundles of tubes, which pretty much forces your hand that you really should do something with a much deeper dive in the turnaround. Because this is really dry ice is really leading edge kind of cleaning.
Yeah.
but we get a camera in there, we can see where the fouling pretty much is holed up, and we'll have a real good idea of what surface area we can address.
All right. Well, once again, thank you, Larry, and thank you to IGS for making this webinar possible. And thank you to all the attendees for joining us and sticking with us through the hour. I hope you found the discussion insightful and can use some of the information that was shared today to improve your own heater maintenance and reliability programs. Thanks for watching and have a great day.
Thanks,
Thank you.
Jeremiah.
Thanks, man.